Welcome pre-calculus students to the homework help video, page 851, numbers 51 through 65 odd. Please get out your homework, your pens, pencils, your books, your calculators, and let's get started. And hopefully this video will help you answer your questions that you have on the homework problems. Let's go ahead and get started with numbers 51 through 59. The directions say write sigma notation. Write sigma notation. So let's start off with number 51. First of all, I've taught you guys to write your terms above each term. So we have 5 terms. Secondly, I notice that I'm adding 5 over and over and over. So really what I have would be 5 times 1, 5 times 2, 5 times 3. Hopefully you're seeing some patterns and learning how to do these on your own. You really should be, okay? Now, let's go ahead and put our Greek symbol here, sigma, and let's take a look. Notice that all of these expressions have a 5, a 5, a 5, a 5, and a 5 right here. All of them have a 5. So I know for sure I'm going to put a 5 right here. And then notice in the parentheses the numbers go 1, 2, 3, 4. Notice term number 1 has a 1 here, term number 2 has a 2 here, term number 3 has a 3 here, etc., etc. So because this number here matches the term, I can just go ahead and put a K right here. Now let's see if that works. Put a 1 in, you get out a 5. Put a 2 in for K, you get a 10. Put a 3 in for K, you get a 15, etc. Now, K is going to start with number 1, term number 1, because you're putting a 1 in first. And then, normally you'd put a 5 here because you have 5 terms, but because of these dots, which are saying the sum goes on and on and on for infinity, you put infinity up here at top. So there you go. You did it. You just wrote this expression in sigma notation. All right, let's continue on to the next problem, number 53. All right, this is term number 1, this is term number 2, this is term number 3, term number 4, term number 5, and term number 6. Now this one's going to be a little more difficult because if you'll please listen to me for a second, all the problems you've done in the past, please listen to me. All the problems you've done in the past that have had alternating signs have started with a negative, then a positive, then a negative, then a positive. And what I've taught you to do is when that happens, you can put n, or excuse me, that's not right. You can put negative 1 to the n power. But that's when the first term is negative and the second term is positive, negative, positive, negative. This is different. It starts off positive. So we're going to deal with that here in a little bit. We'll take care of that at the end, okay? So be looking for that. Then notice here I go 2, 4, 6, 2, 4, 8, 16. All of these are powers of 2. So I have 2 to the 1, 2 squared, 2 to the third, 2 to the 4th. Do you see that? 2 to the 5th. You got to learn to look for stuff like this, guys. 2 to the 6th. So what I've noticed here is this. First of all, I've noticed all of my numbers here can be written with a base of 2. So I'm going to put a 2. Next, I've noticed I have a 1 here and a power of 1. Term 2 has a power of 2. Term 3 has a power of 3, etc., etc. So each power matches the term. So I can put an n right here. Now I should have left myself a little more space, and that's my fault. Let's slide this over a little bit. Now, watch carefully. Actually, I'm going to move it down here just to get a little more room to work with this. Now, watch this. Normally in the past, students, when you've had alternating signs, you've put negative 1 to the n. Now watch, please, why this won't work. Please watch. First of all, I'm going to put a 1 in right here. So if I put a 1 in right here, for negative 1 to the 1, if I put a 1 right here, negative 1 to the 1 is a negative 1. And if I put a 1 here, watch what happens. Negative 1 to the 1 is negative 1 times 2 to the 1 is 2, and I get out a negative 2. And I don't want a negative 2, I want a positive 2. Now if you put a 2 in right here, just trust me, if you put a 2 in, you would get out a positive 4. and you want a -4. So see, all the signs here are really going to be messed up if you use this -1 to the n power. So Mr. Earhart, you taught us to use that before. Yes, I did. But that's when the first term was negative and the second term was positive. So what you have to do now when the signs are alternating and the first term is positive, you have to put n-1 right here. And let me show you why. Watch, I will show this to you, okay? Let's put a 1 in for n. So put a 1 in for n. 1 minus 1 is 0. Put a 1 in for n. Now, anything to the 0 power is just 1, so I get a 1. And then 2 to the 1 is 2, so I get out 2, which is what I want. Now put a 2 in for n, and watch what happens. Put a 2 in for n. 2 minus 1 is 1. Put a 2 in for n. -1 to the 1 power is -1 times 4. I get out -4. And then if you put a 3 in right here for the third term, you would get 3 minus 1 is a 2. That would give you out a +1, and this would be a 9 right here, or 8, excuse me, sorry, an 8, and that would give you a +8. So it does work. So let me review this for you again one more time. Whenever your signs are alternating and the first term is positive, you do not want to put -1 to the n, you want to put -1 to the n-1. So there we go. We've got our expression that goes there. Now, I used n, so I'm going to go ahead and put n right here. N starts with term number 1 and goes all the way to term number 6. And there's no dots at the end. So that's it. All right, let's try number 55. Okay. Now, this is term number 1, term number 2, term number 3, 4, 5, 6. Now, this really is pretty simple here, guys. I mean, there's really no pattern I'm looking for. It's just 1, 2, 3, 4, 5, 6. And then here it's 2, 3, 4, 5, 6, 7. So look, notice the numerators. Do y'all see the numerators? Notice how the numerators match the term number. 1, 1, 2, 2, 3, 3, 4, 4, etc. So that tells me the top of the fraction is just going to be n. Okay? Now the bottom, notice how the bottom, the denominator is 1 more. I have a 2 here, but the term is 1. I have a 3 here, but the term is 2. I have a 4 here, but the term is 3. All of the denominators are 1 more than the actual term, so I'm going to put n plus 1. Now that should work. Put a 1 in, I get out 1/2. Put a 2 in, I get out 2/3. Put a 3 in, I get out 3/4. But now I've got to worry about the signs. So let me slide this over. So notice the signs are alternating, and notice the first sign is negative. So this goes back to what I taught you before. In this case, you would put -1 to the n power. Now you would put n-1 power right here if the first sign was positive and the second sign was negative, so on and so forth, like the last problem. But in this case, the first term is negative, so I'm just going to simply put n. Now, n starts at term 1 and goes all the way to 6. So there we go. Look at that. We're doing really well. All right, number 57. Now, this one's interesting, and you've not been taught how to do these, so please pay attention, okay? You're going to see ... so you're going to think that it goes on to infinity, and that's not true. And let me teach you here what we're doing, okay? Now, first of all, notice that I have powers of 2, 2 squared, 2 to the third, or is that correct? Maybe I'm wrong on that. Let's see. No, that is not right. So let's see what we have here. 2 squared, 3 squared. Okay, sorry about that, guys. Notice the pattern. Well, first of all, let's put the term numbers. Term number 1, 2, 3, 4. 2 squared, 3 squared, 4 squared, 5 squared. Now, first of all, let's notice that all of my exponents are 2's. Do you see that? So I know I'm going to have a power of 2. Now, notice how term 1 has a base of 2, term 2 has a base of 3, term 3 has a base of 4, and term 4 has a base of 5. So all the bases are 1 more than the term number. So then my base is going to be n plus 1. All right, well, let's see if that works real quick. Let's put a 1 in for n, and 1 plus 1 is 2. 2 squared is 4. Let's put a 2 in for n, that'd be 3, that'd be 9. Put a 3 in for n, that'd be 16. Put a 4 in, that'd be 25, so we're good. Now we got to deal with the sign sequence, though. Notice we have a sign sequence issue here where the signs are going from positive to negative, negative to positive. So it's I'm going to put a multiplication sign here. Now in this case, it's starting with the positive sign and then going negative, then positive, negative. So whenever it starts with a positive and changes signs, you do not put in. You do not put in. You put n minus 1. There we go. Now, and here's where it gets tricky. Now watch this. You're like, well, Mr. Earhart, what about this over here? Okay, I'm glad you asked. Thanks for asking. First of all, we're going to put a 1 right here for the first term. Okay? Now, for this right here, what this means is that it's not going on to infinity. It means it goes on and on and on. Now listen to me. For whatever you want to put in for n. And I know that because, excuse me, sorry. I know that because it ends with saying n. So in other words, whatever I want to put in. So it could go to any term. It could be 1 through 4, 1 through 5, 1 through 6, 1 through 7, whatever I decide. So what you put up here is you start with 1 and you go all the way to the what term? To the nth term right here. Okay? Now probably, technically, more than likely, I probably shouldn't have used n and n. Maybe. I mean, I'm not going to split hairs over that. I probably should have put a k, and then a k, and then a k, and then said k starts at 1 and goes to n. Either way, though, that's not a big deal. I'm not going to lose sleep over that. But that is how you do that type of problem. Okay? Hope that answers your question. Let's continue on to number 59. All right, now number 59 here, this is term 1, term 2, term 3, and term 4. Really, guys, they've kind of babied you on this one. They set you up really nicely. I mean, look. I mean, notice first of all, there's really no pattern to look for. They've got it broken down for you pretty nicely. I mean, first of all, notice all the numerators are 1s. So I'm going to put a 1 up top. And then notice in the denominator, all of these numbers here match their terms. First term, second term, third, and fourth. So I'm just going to put an n times. Notice all of these numbers here are 1 more than their term. 2 for the first term, 3 for the second term, etc. So I'm just going to put n plus 1. And that should work. Put a 1 in and you'll get 1/2. Put a 2 in and you'll get 1/6. Put a 3 in and you'll get 1/12, etc., etc. So there we go. Now your n starts with term 1, and it goes all the way to infinity. And there's the term. It's like a sideways 8. There's the term for infinity. So good job. There you go. And let's move on. Now, these are going to be a little difficult, so please pay attention. In the book, the directions for 61 through 65 say, find the first 4 terms of the recursively defined sequence, the first 4. So they give you the first term, and we have to find 3 more. Now, don't just assume, oh, I'm going to put the first term in and get out. Be careful. Always use the formula first and make sure you're doing it right, okay? So I'm looking for the second term. So I'm going to use my formula, which is right over here. So I have a n plus 1. Now I want this right here to be a 2 because I'm looking for the second term. So 1 plus 1 is 2. So I'm going to put a subscript 1 plus 1 equals 1 plus. Now look, please, see this n right here? What did you put for n? You put a 1 right there. So that means I'm going to put a 1 right here for n also. So 1 over a subscript 1. So this is what's going to help me right here. What I have is a 1 plus 1. So that's a subscript 2 equals 1 plus 1 over a subscript 1. What is a subscript 1? It's 4. So 1/4. So 1 plus 1/4. So 1 plus 1/4 is 1 and 1/4. So my second term is 1 and 1/4, or 5/4 if you prefer. Now let's take a look at the third term. Let's find the third term. Let's use our formula. I want this right here to be a 3, so I'm going to put a 2 plus 1 equals 1 plus, now notice what you put for n. For n you put a 2, so for this n I'm going to put a 2, 1 over a subscript 2. So now I have 2 plus 1 is 3 equals 1 plus 1 over a subscript 2. A subscript 2 is 1 and 1/4. So 1 over 1 and 1/4, I'm going to put 5/4. Okay, same thing. All right, and so then a subscript 3 would be 1 over 5/4 is the same thing as 4/5. So 1 plus 4/5 is 1 and 4/5. All right, so a subscript 3 is 1 and 4/5. And now let's go ahead and take a look. By the way, we can go ahead and assume now it's pretty safe. All that we were doing over here was substituting the first term, to find term 2, we put term 1 in, to find term 3, we put term 2 in. Now they're not all going to be like that in your homework today, and that's why I'm warning you. But to find term 4, we're simply going to put in the term before it. So 1 plus 1 over a subscript 3, which is 1 and 4/5. I'm going to put 9/5. And that would be 1 plus 5/9, because 1 divided by 9/5 is 5/9. And so your fourth term would be 1 and 5/9. Okay? So back this up and watch it again if you need to, but that's how you would solve 61. Okay, 63. Here we go. They want us to find the first 4 terms, so we're going to start off looking for a subscript 2. We use our formula right here. Notice it's n plus 1. All right, so here we go. I'm going to put 1 plus 1 because I want this to be a 2 to match this 2 over here. So 1 plus 1. And notice by putting 1 plus 1, that means for n, I put a 1. So equals, so here's an n right here. I'm going to put a 1. And then the square root of a subscript n, which is a1, which is 6,561. Now, 1 plus 1 is 2, so the second term equals -1 to the 1 power is -1. And then, let's see here. The square root of 6,561 is 81. And so -1 times 81 would be -81. So your second term is -81. Very good. So really all that we did, if you can figure this out, I don't want you to do a bunch of shortcuts unless you really, in fact, you know what, I'm going to forget the shortcut because I want to make sure you really get this. We'll do a shortcut on the last term. So now let's look for term 3. So here we go. We're looking for term 3. So I want n plus 1 to be 3. So I'm going to put 2 plus 1. So notice I put a 2 in for n, equals -1. Okay, I put a 2 in for n. So this n right here would be a 2. And then a subscript n, that'd be a subscript 2 because I put a 2 in for n. And the second term is -81. All right. Now, 2 plus 1 is 3, so I have a subscript 3 equals -1 squared is +1 times, now be careful here, we have not done these for a long time since Algebra 2. So the square root of -81 is the same thing as, you can't take the square root of a negative number, students. So you make the 81 positive and put an I on the outside. That's an imaginary number. And then the square root of 81 is 9. 9 times 1 is 9. So I would have 9i. So there we go. The third term is 9i. Okay? And now let's go on to the fourth term. I don't think we'll take any shortcuts on the fourth term either. And we're almost done. This problem, then one more, and we're finished. Okay? All right. Here we go. We're looking for the fourth term. So this n plus 1 should be a 4. So I'm going to put a 3 plus 1. And notice for n, I put a 3. So n is now 3. So -1 to the third power. And then this would be a 3 right here because I put a 3 in for n. So the third term is 9i. All right. Now 3 plus 1 is 4. So I have a to the fourth power equals, and then negative 1 to the third power is negative 1 times, now the square root of 9i, we know the square root of 9, that's 3, but we don't know the square root of I, so we'll leave it square root of I. Now negative 1 times 3 would be negative 3 square root of I, and that would be your fourth term. These are really good problems, guys. They're really going to make you think. Okay, last one, and we're finally finished. This one will be really tough up here, so really pay attention. Okay, notice they've given us already the first term, and notice they've already given us the second term. Isn't that cool? So all we have to find is the third and fourth term. So let's find the third term. Okay, so here we go. Here's my formula right here. There's my formula. So I want n plus 1 to equal 3 because I'm looking for the third term. So I'm going to put a 2 plus 1. That means n is now 2. So equals a, I put a 2 for n. So a, actually I'm going to do it up here. I put a 2 for n right here. And then I put a 2 for n right here. So a subscript 2 is what? A subscript 2 is 3. So put a 3 plus a subscript 2 minus 1. 2 minus 1 is 1. So a subscript 1 is 2. And so when you add those together, you are going to get, let's see here, I would get a sub 2 plus 1 is 3, so a subscript 3 would equal 5. So we found our third term. A subscript 3 is 5. Let's go ahead and quickly now find the fourth term, and we'll be done. So good deal. Here we go. All right, let's go ahead and find the fourth term. Let's use our formula. We want n plus 1 to be a 4, and so we're going to have a 3 plus 1. And so it looks like I put a 3 in for n, so I would have a 3 right here, a subscript 3, and this would be 3 minus 1. So a subscript 3 is 5, we already found that, plus 3 minus 1 is 2, so a subscript 2 is 3, we already know that. So here we go, 3 plus 1 is 4, so term number 4 would be 8. Term number 4 would be 8. I always glance and check the answers to make sure I'm right. Yep, that is correct. And so we're good to go. I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.